Today we're going to talk about I to the I. I is a complex number. It's an imaginary number. So a complex number is made up of an imaginary number and a real number. And I is the imaginary number, which is defined as I equals the square root of minus 1. So I squared equals minus 1. Now you'll notice here, even though I is imaginary, if we square it, we get a real number, minus 1. And we can raise it to a third power or a fourth power, or any power we like. However, there's something very special about I, and that is it's 4 periodic. So every time you raise it to a fourth power, it loops back. So I to the 5th is I to the 9 is I. It just keeps looping in increments of 4. So I squared will be equal to I to the 6, which equals I to the 10, and so on. I cubed equals I to the 7. I to the 4th equals I to the 8th, and so on, which incidentally equals I to the 0, which we know is 1. So I'm going to draw a little flow diagram, and you'll notice I at the top and minus I at the bottom. They're in black, they're imaginary. And then on the west and the east you've got green, which is real numbers, 1 and minus 1. Try and memorize this, guys, it'll be very useful. So we're going around in a clockwise direction, and each number is basically the previous number multiplied by I. So I is just I to the 1, then I squared is minus 1, I cubed is minus I to the 4th is 1, I to the 5th is I. We're back at I. And it just keeps looping like that. So I to the I, what is that? To solve this, we need to use Eulers Formula. Eulers Formula states that e to the power of ix equals cosx plus I sin x. So it connects I, e and the sine and cos functions for some variable x. In general, x can be a complex variable. So e to the ix equals cos x plus I sin x. So we'll let x equal to pi over 2, and that will become clear in a moment why we're doing that. So pi over 2 is in radians, which is 90 degrees. So e to the pi over 2 is equal to cos pi over 2 plus I sin pi over 2 by Euler's formula in yellow. We've just plugged in x equals pi over 2. Now you can go on your calculator and work out cos pi over 2 and sin pi over 2. Make sure you have radians selected as your unit, not degrees. If you want to convert it to degrees, then it will be 90 degrees. So e to the I pi over 2 is equal to 0 plus I times 1, because the cos of pi over 2 is 0 and the sine of pi over 2 is 1. Go on your calculator, you can check that. Cos of 90 is 0, sine of 90 is 1 in degrees. So therefore, e to the power of I times pi over 2 is just I. 0 plus I times 1 is I. Or I equals e to the power of I times pi over 2. So we're nearly there. So now we've got I equals e to the I times pi over 2. So I to the I is equal to e to the I times pi over 2 all to the I. So when you have something in a bracket raised all to another power, you just multiply the two powers together. So we don't really need the bracket here. I'll just put I to the right hand side. And what we're doing there is we're multiplying the first power, I times pi over 2, multiplying that by I. So I to the I equals e, and then we'll join the i's together to get I times pi over 2. So I times I, as you know, is I squared, and as we already established, that equals minus 1. So I to the I is therefore equal to e to the power of minus 1 times pi over 2, which is e to the power of minus pi over 2. Which numerically computes to around 0.2079. You can check that on your calculator. Now in general, I to the power of I to the 4n, where n is any integer, like 0, 1, 2, is just I. So if you let n equal 0 there, I to the power of I to the 0 is I to the 1, which is I. In our case, we had I to the I. So this next generalized formula comes into play. So in this one, we let n equal 0 again, and we get I to the I to the 1, which is I to the I. And that's equal to e to the power of minus pi over 2. And we've already worked that out. However, if we plug in any value of n there, 0, 1, 2, 3, 4, up to infinity, we'll get the same answer. So I to the 5th would give us the same answer. I to the 9th, etc. I to the 4n plus 2 is equal to 1 over I, which is also equal to minus I. It's entirely up to yourself which one you want to use. And finally, I to the 4n plus 3 is equal to e to the pi over 2. So the power is positive here. And that's also a real number. And like we did before, for the just I to a power, we draw another flow diagram. And this time, when we move clockwise, instead of multiplying by I, we're raising to the power of I. So the next number is the previous number raised to the power of I. And again, it will be 4-cyclic or periodic. So here we have I at the top, minus I at the bottom. They're both imaginary. And then e to the pi over 2 and e to the minus pi over 2 on the left and the right. They're green. They're real numbers. So if you start with I at the top, raise it to the power of I to go clockwise, you get e to the minus pi over 2. And then if you raise that to the power of I, you get minus I. If you raise minus I to the power of I, you get e to the pi over 2. And if you raise that to the power of I, you get back at I. It's quite cool when you think about it. So there's two useful flow diagrams, 2 4 cycles that are very useful to remember, which might help you in an exam question. So that concludes the video. Have fun with I to the I. Thanks for watching and please subscribe, and I'll see you on the next video.